Okay, good evening. Uh, so today we will see housing prices prediction using multivariable regression. So before this, we have already used linear regression, but we have used only single variable to detect whatever the dependent variable is. So it's like we have used coefficient and a single linear regression. But we will be using the same linear regression machine learning model, but here we will have different I mean to say different dependent variables. For example, so here, so depend, uh, so we will be using Boston data set. So where the prices will be dependent on different uh, parameters, which is called variables. You can say, for example, the number of rooms in an apartment, or the distance from the employment centers, or how rich and poor the area is, or how many students are there per teacher in local schools. So depending on different factors, we will be build the model, and we generally we use linear regression to predict the housing price. For example, just I will show you, for example, this one. So actual predicted, like residual predicted values. So we will be seeing all this. So here, yeah. So this is our like movie based prediction. I think we have already did, so it's a long time we already seen that. So here we have a total of 13 features. So we will be using different, for example, all this uh, different features to predict the house. So let's see what exactly the price is, and what exactly we will be doing. So the introduction is the same thing, like we will be working, for example, we just go back to 1970s, where we are just imagine we are working as a real estate development company. So we need to evaluate how the prices will go depending on different uh, tasks, like characteristics. So for example, already we have seen the same thing. So here, so what we will be doing, we will be first what analyze and explore the data. Already have shown Boston, split our data for training and run a multivariable regression. We have to evaluate how our models are performing. So using data, and estimate the property price. So this will be all these steps we will be doing, but today I think we will be seeing only analyzing the data. Tomorrow we will be seeing, tomorrow and after, maybe day after tomorrow we will be seeing the remaining steps. So generally, as usual, we already provided the same starting notebook. You can unzip and upload to your Google Drive and open it as a Google Colab notebook. The same CSV file also there. You can just add it to that. So for other characteristics is like this one, as per capita income. So these are the characteristics, like this is the price where we have to check. So this price is dependent on this parameters. So maybe I think okay, let's go back. So let me just go back to, so it's the same thing. So here we are updating plotlet. So just I'm running it. So here we are importing our import statements. So we will be using pandas by default, numpy, cbar, plotlib, matplotlib. So all these are data visualization libraries, and this is the machine learning library where we So where we will be using linear regression model, but we will be using multiple variables. So here scikit-learn. So this is to split data, because whatever we have is we will be using it as some sample data as train data and test data. So that will automatically split. So we have to give the percentage how to split it. So that also we will be seeing later. So it's just a format thing, like up to 2 decimal points we have to display. So that's what we are notebook formatting. So the first let's read the data. So here already I uploaded to the same notebook. So I have loaded my data boston.csv into a data variable, which is a data frame. So here the number of instances, so the characteristics what they are already given. So even in Google Colab notebook at the starting also you will have the same thing. So there are 13 numerical category predicted. The median value of attribute 14th is the target. So that's what this is the target. This is the dependent variable where we need to predict the prices depending on all these factors. So for example, if you see it's a per capita crime rate by town, crime rate. So residential land zone or 20,000 square feet. So non-retail business acres per town. So there are different level. So if it is nearby Charles River, it will be 1, otherwise it will be 0. So if it is the location is nearby a river or not. So it's like nitric oxide concentration is like the air purifying quality. So average number of rooms per apartment. Okay, system. And the age owner occupied. So how many in that area, how many are occupied? So prior to 1940, and the distance from employment centers. So this is again, so it's like because if there is employment centers, like for example, if you take Hyderabad, if take high tech city, the nearby all the areas would have higher prices because all the software companies are in high tech city in Hyderabad. So depending on areas also the price will vary. So this is the weighted distance of employment centers from which the price will be vary on the highways also. So for example, what is because of and for example, if you want to do a certain business, transport business, so for that kind of stuff, highway should be near. Even for, even for accessibility, if highways are near, the prices might increase depending depending on how frequent it is. So even the tax, depending on tax, so certain areas have certain taxes. For example, in India context, rural areas like villages will have less tax property tax rather than the cities. So similar concept will be applicable in Boston also. So it's like the same teacher pupil ratio. So it also takes in consideration like how many students are there for teacher in that town. So here because it's Boston is near, so how many blacks are there? So they generally divide like whites and blacks. So yeah, and the lower status of the population, how many are lower income people are there in that. And this is the main what we need to uh, price what we be predicting depending on this data. So this is again the data set which is already there. So it is from this research paper already available. So the copy of machine learning housing data set. So now let's see what are the preliminary data exploration. The same thing we have mentioned here also. Shape of the data, what are the challenges, like so we'll be seeing one by one what is the preliminary data exploration and descriptive statistics. Generally, whatever project you are doing in machine learning or AI, we have to first check the whatever data is available, and we have to do the preliminary data exploration and then statistics exploration. So we will be doing that. So what is the shape of the data? So it's like 506 rows and 14 columns. The columns is already we have seen. And if you see just for our reference, yeah. And here the head, so it's like the top five we are returning, and okay, the first thing I forgot to mention, yeah, the index column. So we have kept index column is 0 because the first, if we just open boston.csv, so the index, the first column will be something like 0, 1, 2, 3, something like this. So we have set, because index starts from 0, we have set this index, this first column as an index. So that's why we have given index column equal to 0. So generally in pandas we have flexibility to define what is index column we need. If it is not defined, by default it will add one index column by default. So because we already defined, so it is having the same index column. So we are checking just the tail data, last 5 rows. So this is the how price varies. Again, other prices in the thousands, like for example, if it is $24,000, something like that. So in $1,000, this is everything. So now if we do the count number of rows, so for every column we have 506 rows are there. Everything is in. So now we are checking for missing values. So all this we have already did for before also, even in movie budget prediction also we have did the similar exercise. But whenever we are starting, we should do all this kind of stuff, data exploration, it should be done, so that we will get to know what are the data types, or any data is missing, or there are duplicate data, or there are any nan values. So here if you see there are no null values, everything seems fine. Even we can use the same is any method value dot any. If any, it will return true, but if there is no nan values, it returns false. Even the duplicated values, if there are any duplicates, it will return true, but there. So yeah, this is the preliminary thing. Then we will going to descriptive statistics. So here, this also we have already seen the describe method. So here the challenge, how many students are there per teacher on average. So for this, it's like the mean value of the I think PT ratio, because pupil to teacher ratio. So whenever we take a mean, so it should be 18.46. So what is the average price of a home in the data set? Average price of home is like $22,000. So if you see average price, what is the CHAS future? CHAS, this one. So the max, if you see max and the min, so and if you see it has only value 0 or 1, this kind of is almost dummy variable. If the column is having only 0 or 1, if it is near this is called a dummy variable. This kind of feature in a data set it is called. So the average is like 22.5. So when we multiply 10,000, so it's like $22,530. Yeah, this is way back in 1970s. So that's why it is very lower in cost. So what are the maximum and minimum rooms per dwelling in the data set? So rooms are, I think, to check what rooms per, yeah, average rooms per dwelling. 6. So if I just check what is the minimum, it's like 3.56 and max is 8.78. So it's like you can say 3.5 or something. So because they have already just given, already it's a average rooms per dwelling. So in that, if we are taking minimum value and the maximum values, so it's like 3.56 and 8.48. So here, so now we will be visualizing our data. So using Seaborn this plot, I already opened here. So this is for example, just if we do an Instagram plot and if we run an normal graphs on top of that, we will be using this kind of plots, like a disk plot. So in that also we have different kind of plots, like histogram. By default it will be histogram, but if you want to change this Calideo plot, we will be seeing one by one what exactly those will be. So now kernel density estimate of the following bar chart and superimpose kernel density estimate. So for the following variables, okay. So for a price, the housing price in thousands, RM the average, the okay they have given for these variables, and aspect parameter 2 for a vector picture. Okay, so aspect parameter is nothing but again okay, for each facet, so height width, like the width of each facet in inches. So what is that facet we will see? So for example this one, the width of this line. So here we are just calling, for example, if you see C bar and this plot, and we are plotting only a price variable, like price column, and aspect equal to 2, kernel density, yes, we are plotting, we are giving color, and let's see what are the bins. So how many uh, bins are there, like I think this one, like Okay, it might be how many? Okay, how many? This one. Okay, let's see if I just change to 40, and if I just change to 3, how it will behave. Let's see. Okay, the facet is changed. So it's like if you see, so kernel density is nothing but it draws the this kind of sine wave like a graph. Okay, just let's check once. Okay, so we have used generic when that can be never referenced from the. So because we by default it is using histoplot, and so we are just using the bins. So this is the bins where it can be a string number or a pair of such values that can be new of a difference rule. Okay. I am thinking the bins is like this one. Okay, let me just change to, it's like y-axis kind of okay. Anyways, so okay, so here we are plot values and the average. Okay, the average. So here just we are giving the graph title and X label in price in thousands. I think it should be thousands. Number of homes here. Just change to 10, how it behaves. Okay, so it is like how many, okay, how many bins it is performing. So like how many plots it is drawing, how many graphs it is drawing. I think that's the bin value. So for example, if I just change to 30, how many histograms it is. Perform. Okay, yeah. So it is changing accordingly. So in this section how many different plots it is doing, and what is the estimation. Yeah, even if you see here, there is a very high spike in number of homes at 5000 mark. So the same thing if you do for DAS, distance to employment uh, thing, and if you use the same aspect ratio, so if you run it, if you just do 20 just for our reference purpose. Yeah. So nearby only there are more houses, but if the distance goes up, further up, the houses are very less. So this we can implement. So again the same thing if I run rooms per area. So we are using the same number of homes. So it is around 6. The average is 6.3. So here again we are doing the same thing, average dot mean, and we are just displaying point to it's like a single decimal. So access to highways here, haven't displayed a KDE plot. So if I want to display KDE also we can display. So here we have given just histogram. So hist plot. So we can use this. Or if we are using the same histoplot, bins color is different. So it's like histogram plot. So if you see here, there is a black color around thing, right? So that is easy. For example, if I just change to white, so there is no, we can't see, right? We just check. Yeah, you can clearly see it's the outline of what we are drawing for the this one. But if you want to plot the similar kind of stuff, I'm just removing this for the time being. So yeah, so we have forgot comma, so that's what it is saying. Yeah, yeah, if you see here, there is a big gap between number of houses nearby highways and very far from highways. So even a KD plot also similarly we have plotted. So because this is just for visualization purpose, we just select this one. So from graphs we can clearly see it is there is a big gap. So now let's there is another thing, next challenge. Let's go to next challenge. So everything here we are dealing with data visualizations for as of now, so that we will getting the clear idea how the exactly the data is in the uh, data frame whatever we have loaded. So here what it is saying, plotlay for CHAS. Already we see this a dummy variable where we have only zeros and ones. So it's like S or no, x-axis no, or s. Okay. So what we are doing, axis data, so value counts, so our axis. So the value counts, what it will do, it how many ones are there, how many zeros are there. For that, it will give us the counts. So we are storing that data in this our axis variable. Okay. So we are just plotting bar plot on x-axis. We are giving a no rs. On y-axis we have the values. So how many it is coming, and color, it will, the color also it will change accordingly. So we are taking this is again continuous scale, so it depends on uh, I meant to say depending on this one, like how many are there, the colors will vary. So the title of the chart is next to Charles River. So update layout, so property located next to river and number of homes by title and color axis. So as of now we haven't shown color axis. So if I just run this, and I will run after changing it to true also. So as of now it is saying this. So I'm just changing to true. So it will see. So this is the color axis. So because it is at 100, uh, it is it plotted in this. But if it is above 400, it has plotted in this color. So it's like Halen. So I think we have already seen this kind of color axis in previous chapters. You can refer to plotly uh, graphs. So if you want to just check how what exactly this it is doing. So here this one, yeah, for charge variable it is actually for 0.00 there are 471. I meant to say the count is like for this value there is 471 records are there, and for one it is like only 35 records are there. So generally we will be plotting 0 or 1. So but we have given just x-axis no rs. So 0 it takes as no, and y-axis as 1. Yeah, so if you see out of 506, only 35 located near to Charles Tower. Now this is again another interesting data visualizations, a pair plot. So there might be some in the data that we should know about before you run the code, make some predictions. What would you expect of relationship between pollution and the distance to employment? So yeah, what kind of relation do you expect? So generally, whenever there is more employment, there should be more pollution, nitrous oxide, because due to traffic or due to usage of more vehicles, it should be higher. So we are expecting near employer and NOx should be higher. What kind of relation do you expect between number of rooms and the home value price? Obviously, if the rooms are more, the price of house price will be increasing, right? So that is one identification we can say. And what are the amount of poverty in area and home prices? Yeah, so if there is a more poverty, I think that area should have less prices. Yeah. So if you want to just pie plot, pie plot is again it will plot everything, whatever the data we are given. It will plot everything, all the columns related plottings it will do depending on different things. So we can change. So for example, if I just this is the pie plot, pairwise relationship. So it will plot accordingly first column, second column, and grid of such each numeric variable will be shared by the y-axis across a single row and x-axis across single column. We can actually plot different by giving certain rows and columns. But if we just want to plot everything, for example, it is plotting all the columns and it is. So if you see, it's like price, CRM relation, price, ZN relation. So all the columns it plots. So it is very huge thing. So that it will take time because it plots every column to column mapping. Like I already shown you, right? So, okay, let's wait because it will take at least 1 2 minutes. So even we can plot KWS already shown kernel density estimate. So we can kind that also we can plot. It's like so we can see a pipe like even like for example it's a price and CRM mapping. For example, it's LSAT and CRM mapping like that. It is plotting. So it plots every column to column, like yeah, even x-axis, y-axis, the same plots. Scatter plots. So all this, if you see, these are scatter plots, but if it is a diagonal, like for example price versus price and LZ versus LZ, so it's like that, it will be histogram. So just to differentiate, so x-axis again this column B versus B, it will be histograms. So the next thing is a similar kind of thing, the pair plot, but it's a joint plot. Joint plot is like a plot of two variables with bivariate, univariate. So it's like, for example, if you want to plot against distance and knocks, already the same thing we have discussing, right? We have already answered. So because if there is an employment center near, the pollution also should be greater. So the same thing, let's go challenges one by one. So yeah, distance from employment address using joint plot, does the pollution go up or down as increases? So here on x-axis we are using distance, y-axis distance from employment centers like knocks. So how much height we are giving, and scatter plot. Color is like deep pink, joint KWS. Alpha again, for plot components. So joint KWS dictionary. So here we are already seeing the same alpha again. Alpha is again derived. Already we have seen above to give 2, right? So here we have given only 0.5. So height we have given only small. So here the kind is a scatter plot. Okay, let me just change to 50, 15. This is to 2. How it behaves, let's see. Okay, so for this, okay, in joint plot it should be 0 to 1 range 1. Let's see. Okay, it because it's increased grid size. 0.5. Yeah, because I have increased height to 15, so it is the plot also it increases. So this is the plot. So generally uh, it decreases nitrous oxide. So if we taking consideration of number of houses, so on x-axis the distance, right, distance from employment center decreases. y-axis. So for example, so inox, the scatter plot, these are here more concentrations are there, but if the distance got increased, there is very less concentration. If you see here, nitrous oxide here, so pollution goes down as we go further. This makes into two. Yeah. So distance at 2 miles, it is having more dense pollution rather than at 12. Here it is plotting just the values according inox values. So that's histograms is different dependent on different. Now again, if we use the non-retail industry and factories, so the same kind of stuff here. We again, if we just, so it is taking a scatter plot. If I just change kind to hex, so by default it will take a scatter plot, but whenever we have changed it to hexagon, it's like hexagon. So here the hexagonal plot is, if you see, observe carefully, observe, very deep is very deep colors are there. So yeah, so when there is a less non-retail industry, there is a less pollution. But when there are more less pollution, in the sense the nitrous oxide values is less, so that's why it got a very dense kind of stuff. So because if there are more industries, obviously the nitrous oxide also increases, but the values are not correlating, so not uh, correlating that much, because the industries are very less, so that's why it is actually plotting only less kind of stuff, like less nitrous oxides, that values as it is populating. So now again, so lower income population versus average. So if I again see, yeah, so lower income people percentage, if you see here, it's in the top left corner. it is less than uh, 8. If there are more 8 or more rooms, only rich people can afford. That's for lower income people. LSAT is well below, less than 10%. It actually, if you see, it is actually less than 5% also. Like more concentration is at less than 5% of people only, where there is a rooms greater than 8 are there. So lower income person versus house price. So this is we have already talked about, right? So again, so lower income people. So it's like average. It will be here more, but very less rates. Also, there are very less density of percentage of lower income people. But again, if you see, if it is the price is more than $50,000, uh, so then it is actually only 5% of people are there. So above this, it is very low. So generally, it is around $10,000 to $20,000, where most of the lower income people are percentage people are there. So again, the prices increases. The price, if it is around $50,000, obviously there is uh, only 5 bedroom. Here there is number of rooms is like more than 8 or like below 9 or 8. So it's like around $50,000. Yeah. So, yeah, $50,000. All this the max, I think. So that's why it's also same. Yeah. So today we have visualized all this. So tomorrow we will be seeing training and test data, and then the multivariable regression and how it is behaving our model, and how to do different techniques to increase our model prediction, and that everything we'll be seeing tomorrow. Yeah, thank you.